Okay, so this is Unit 6, KA. Let's go ahead and get started. So number one, we want to add these polynomials. And so you can ignore the parentheses since we're just adding and we're just going to combine like terms. So I have a 2x and a 4x, which gives us 6x. And then 9y plus 7b. And that's it. Okay, so subtraction, so there's one thing you have to keep in mind, that minus sign. You're going to have to distribute that minus sign. Okay, so we're going to have 5x minus 1 minus 3xy minus c. And then if there are any terms you can combine, you can go ahead and do that. Which there aren't, so this is our final answer. Okay, so number 3, now we're multiplying. And to multiply polynomials, we're going to double distribute. So I have the 7a, and we're going to multiply with the x squared. We're going to multiply with the 2x and the minus 5. So what do we get? We get 7ax squared, and 7a times 2x is plus 14ax. 7a times minus 5 is negative 35a. Okay, and then we're going to distribute the minus 1 to the x squared, the 2x, and the minus 5, and we get minus x squared minus 2x plus 5. Okay, so after you double distribute, then you combine like terms, but it looks like there's no like terms here. So our answer is, let me see, this one. Okay. Okay, so 4, the triangle of numbers used to find the pattern for any power of binomials is called Pascal's triangle. 5, each number in Pascal's triangle is the sum of the two numbers directly above it in the previous row. Okay, 6, we're going to factor the polynomial. So what you need to know is we need to know the sum and difference formulas. Difference, and it's the sum and difference of cubes. And what that states is if we have the sum of cubes, so meaning they're adding, we're going to factor them, and they're going to look like this. A plus b times a squared minus a times b plus b squared. Okay, and then the difference of cubes is a cubed minus b cubed. And those factors are going to be a minus b times a squared plus a times b plus b squared. And we look here, we have a difference of squares. So we're going to be using this. So first we need to find what a is going to equal and what b is. Okay, and since these are cubes, what we're going to do, we're going to take the cube root. So cube root of x cubed is x, so that's our a. And then cube root of 27 is 3. So now we know what a is, we know what b is. Now we're just going to plug them in. So it's a minus b, so x minus 3, times x squared plus 3x plus, what's 3 squared? That's 9. So our answer is this one. Okay, so shortcut method of dividing a polynomial by a linear polynomial by using only the coefficients of the terms of the polynomial is called synthetic division. And we're going to see an example of that. So y'all should have the equation. It is x cubed minus 2x squared minus 23x plus 60 divided by x plus 5. So when we're dividing this and we're doing the synthetic division, we look at the coefficients first. So if we don't see a number for the coefficient, it's 1, and you just write those down. So 1, -2, -3, and then you write the constant, 60. Okay, and then right here, the x plus 5, you set it equal to 0, and we get that x is -5, so that's where that -5 comes from. And then whatever ends up in the last row or the last column, so I do like a little box here, that is your remainder. Okay, so there's a process to this, and the process is that first number gets dropped, and then once it gets dropped, you're going to multiply by that -5. So -5 times 1 is -5. And then we're going to add -2, -5, which gives us -7. And then you do the process again. We're going to multiply -5 with -7, which gives us positive 35. Add it to -23, you get 12. And then 12 times -5 is -60. 60 minus 60 is 0. So we get a remainder of 0. Okay, so now we need to write our answers when you bring back the x terms. And since in the original problem, it started with a cube, your answer is going to start with a square and then go down. So you see how the degrees go down, 3, 2, 1, and then node x. So that's what we're going to do. It's x squared minus 7x and then plus 12. So that is your answer. Okay, so 9, the numerators of any rational roots of a polynomial will be the factors of the constant term. 10, the denominators of any rational roots of a polynomial would be the factors of the leading coefficient. And then 11, the graph of the inverse of a polynomial function is the reflection of the graph of the polynomial function over the line y equals x. Okay, 12, we want to find the inverse. So first step to finding the inverse, if there was an f of x, we would change it to y. 2, we would switch the letters x and y. 3, you would solve for y. And then 4, you would change the y to the inverse function. So in f to the -1 of x. All right, so we don't have to change f of x to y. So we're going to go to our second step, which is switching the x and y. So x goes here, equals 5 times y minus 10. Now we're going to solve for y, or get y by itself. And we do that by first adding 10 to both sides. So we get x plus 10 equals 5y. And to get rid of that 5, we're going to divide both sides by 5. That gets canceled. We're left with y, and then I'm going to divide each term by 5, so x over 5. What's 10 divided by 5? 2. And then normally we would change this to f to the -1. Oops. But our answers aren't set up that way, so we can just look here, match it up. It should be this one. Okay, so 13. They say to apply the horizontal or the vertical line test to determine if the inverse of the function is a function. So if you recall in algebra, if we had some crazy graph, like this, oops, or I don't know, something like that, and you had to determine whether or not this graph was a function, you would do the vertical line test, right? And it should only hit the graph once. Anywhere you would draw that vertical line. Okay, right, vertical line test. But since we're looking to see if the inverse is a function, we're going to apply the horizontal line test. So if I do the horizontal line test, you notice that the line hits the graph more than once. So that tells us that this is not a function. So the inverse is not a function. At 14, find the composition of the function f of g of x. So what does that mean? That means you're taking g of x and you're plugging into the f equation. So we're taking this g of x and we're plugging in where the x is in the f function, the f equation. Okay, so we're going to have 2, and then instead of writing x, we're going to write the g of x equation, x divided by 2 minus 1, close parentheses, plus 2. Okay. With that 2, we're going to distribute. So we get 2 times x over 2 minus 2 plus 2. This cancels, and then minus 2 plus 2 is 0, so we're left with x. Okay, so number 15, the domain of a polynomial function is always all real numbers. 16, if the highest exponent of the polynomial function is odd, then the range of the function is always all real numbers. And that is it. So let's go ahead and go over our answers. So starting with number 1. Number 1 is 6x minus 9y plus 7b. Number 2 is 5x minus 1 minus 3xy minus c. Number 3 is this one. It's really long. 4 is Pascal's. 5 is sum. 6 is this one. 7 is synthetic division. 8 is x squared minus 7x plus 12. 9 is constant. 10 is leading. 11 is inverse. 12 is y equals x over 5 plus 2. 13 is no. 14 is x. 15 is domain. And 16 is odd. Okay.